Have you ever used a free or extremely cheap proxy service? It might be a good chance that your traffic is illegally routed through a random router, smart camera, or any other internet-connected device of a random person in the world. It might even be possible that your devices at home are already part of this proxy network, and some random person's traffic to some strange website is running through the wires in your house. However, this happens more often than you might expect, and it is all possible by a malicious cybersecurity concept known as a botnet. You can think of a botnet as a coordinated network of internet-connected devices infected with a specialized malware known as a worm that is under the command of a central server. A worm will require an initial infection vector in the form of a software vulnerability introduced by means of a programming bug or mistake. We will discuss more about this later on. Let's take a visual approach to better understand how a botnet works. After each device is infected, it will be controlled to connect to a central server known as a command and control server, or C2 for short. You can think of it more simply as a leader, where all the infected devices will retrieve commands from. Each infected device will constantly retrieve updates from the C2 server of what commands to be executed. This is the primary means of communications between the C2 server and the infected devices. This brings us to the next point. In everyday conversation, we hear the term proxy being thrown around as a technical jargon. But what exactly is it? A proxy server acts as an intermediary between the user and the internet. When you visit a website through a proxy, your request is routed via the proxy server. This proxy server will forward the request for you, effectively masking your real IP address. They provide a few key components such as privacy and access to geographically restricted contents. Let's take a look at another diagram to better understand how a proxy works. Whenever a normal non-proxy user visits a location on the internet, for example a website, the usual route taken by the network traffic will be through the internet and directly to the target destination server, without having an intermediary server in between. As a result, the source IP address will be that of the actual user. This means that the destination server will be able to identify the actual origin of the request. However, with a proxy setup, the network traffic of a proxy user will be forwarded through the proxy's gateway infrastructure on the internet, and eventually the destination target server. More specifically, each infected device from the botnet acts as a residential exit node within the proxy network. As a result, the proxy user will remain anonymous, as the source IP address will be that of the infected device, and it will appear as though the request came from the residential network of that particular device instead. Imagine if your home router was infected by this malware, and a criminal uses the illegal proxy to route traffic through your home network to mask his or her identity to perform fraudulent and malicious activities. The police may come knocking on your door, thinking you're the one who performed those bad things instead. You must be thinking now, so how does my device become part of a criminal proxy network? And how do I know if I'm already infected? This brings us to the main topic of this video, where we explore how a few simple IoT programming mistakes created a massive criminal proxy industry, known as faceless. The faceless proxy service gained traction by exploiting a range of software vulnerabilities in routers around the world. One of the most prominent ones is known as command injection. As the name suggests, this refers to injecting commands into computer programs. As a result, the computer may be tricked into executing a malicious command of the attacker's choice. Since we all know computers are simple do whatever I say kind of machines, it will obediently listen to every single command given to it without question. Thus, it is up to programmers to explicitly make the computer check and filter for malicious commands. It may come as a surprise to know there are a large number of routers such as the Linksys E-Series, ASUS RTAC66U and RTN66U, D-Link, DIR815, VivoTech Network Camera, IB8369, blah blah blah. Okay, get the idea that there are a lot of routers out there actually vulnerable. If you purchased your routers more than 10 years ago, I recommend you disconnect it from your network for good. These routers are vulnerable to the command injection vulnerability, and due to certain types of misconfigurations, they are commonly exposed to the internet. So, with the spreading capabilities of a worm, even with only a few infected devices at the start, it can easily spread from one device to another, leading to massive numbers within the network. This was a process exploited by a botnet named the Moon, which infected a range of devices and contributed to the massive scale of the faceless proxy network. If you're interested to learn more about the background of the Moon botnet, do check out the video that I will link at the end of this video. So, as simple as that, with just a few bad programming practices and a lack of security validations within the code, tens of thousands of devices on the internet have been infected. Now, let's take a look at how we can prevent this. This attack can be prevented from a point of view of a programmer and an everyday user. From a programmer point of view, it is important to take note of the functions that are vulnerable to the command injection attack. A very common example would be the system command. To make the attack harder, you can add a validate input function to validate the input before it is passed to the system command. But even so, it might be possible to bypass the filter mechanisms. Thus, it is better to completely refrain from passing user input directly into the system function. While as an everyday consumer of routers or any other IoT devices, we should practice security hygiene by having strong and non-default passwords, updating firmware, and not expose services on our devices to the internet without a good reason. Fortunately, most routers nowadays come with an automatic firmware upgrade mechanism. If you have not updated your router firmware and have exposed them to the internet, chances are your device might already be part of this malicious network of infected devices. Also, if you happen to be using one of these vulnerable devices and you want to check if you are infected, well, there's no easy way to do this actually, as it will require you to pry open a casing, connect to a terminal, and analyze the file system. An easier fix will be to simply smash a router on the floor and never connect it back to your network again. But not to worry, as recent reports showed that the criminals involved in the faceless proxy service have been arrested, and many online websites selling the services have already been shut down by Operation Moonlander. Unfortunately, there has been a new variant of a botnet named Catnap that gave rise to a criminal proxy service known as Doppelganger. That is a topic for another video. Do not worry if you are still confused about the technical details on this topic. Stay tuned for the next video, where we will walk through the technical analysis of this vulnerability, where I will demonstrate a practical scenario of how threat actors can exploit it. Also, check out the video over here to learn more about the background of the Moon botnet. I hope you enjoyed this short documentary on the faceless proxy. Comment down below which part of the video you enjoyed the most. Also, I would appreciate it if you could consider subscribing to my channel to learn more about IoT hacking related topics.